I want to start today by making some notes on syntax and also some notes on notation, but some notes on syntax. Fraction exponents and coefficients are going to need parentheses when we go into a single line like we had to type on Canvas. So if we wanted to express 3/5 x to the negative 2/5, that's how we would write that if we were just writing things on the paper. But if we're going to type things in single line syntax, for example, in an answer on Canvas or in a text to your friends during a test or something like that, you need parentheses around the fraction. The fraction not only represents a fraction quantity, it also represents an operation. And we got to make sure that our order of operations is correct. In this case, we have 3 divided by 5 times x. It's not, it's without the parentheses around the 3/5, we are still taking the 3, dividing it by 5, and then multiplying by x. But we don't always read it that way. So we can't write it that way. If it's not something that we're always going to read, if not everybody is going to read it the same way, then we can't write it that way and be clear. So if we want to write this expression with the negative exponents, we want to say 3/5 times x to the negative 2/5. The other acceptable way to write this with a negative exponents would be to say x to the negative 2/5. But to keep our everything nice and clear, we want to separate out our operations. So some of you were writing this and correcting, or not correcting, but simplifying the negative exponent. Some of you were trained in your algebra classes to not write negative exponents, and you were trained that that was not simplified. So we could simplify this expression to just have the 3 and 5x to the 2/5. So that's how we might write it by hand, 3 over 5x to the 2/5. Now, in this case, I have a numerator and a denominator, whereas I had 2 factors. The 3/5 had a numerator and denominator. The x had an exponent. Now I'm writing a numerator and denominator. I have written this as one fraction. So my numerator is just a 3. I don't need parentheses around the 3. But we're dividing by 5x to the 2/5. So we're going to need parentheses around the 2/5 because there's an operation. I don't want it to, otherwise I would read, if I just write this as 5x to the 2/5, x is going to get squared and we'll be canceling out the 5s. That's not what we're trying to do here. That divided by 5, that's part of the exponent. So we need parentheses around that fraction exponent. But just as it's written here, most of us would read that x in the denominator. But the other most of us would not read the x in the denominator. In particular, if we just type this on some kind of computer to do this calculation, that probably would not read the x in the denominator. Since not all of us would read the x in the denominator, we cannot write it this way. It is unclear. People will not know what we mean. We might mean 2 different things to 2 different people. That's poor communication on our part. So we want to remove any ambiguity. We're saying it's 3 divided by all this shit. So we need parentheses around that whole denominator. The denominator has operations in it. The denominator has operations. So we need parentheses around the denominator. If your numerator or denominator has operations in it, you need to separate it out with parentheses. So if we want to say 3 divided by the product of 5 and the 2/5 power of x, we'll need parentheses around what we're dividing by. Leaving those parentheses off, we might interpret this as 3/5 and then times x to the 2/5, putting the x to the 2/5 in the wrong place. Does that make sense? Finding out who gets along with this kind of thing is like separating the class into Pathfinder players and Blades in the Dark players. Kind of like, depends on how crunchy you want your system to be. You're like, oh, no, I like Pathfinder. Nice crunchy system. You're gonna be like, oh, yes, this is perfectly acceptable. Narrative gamers are like, oh, this is a pain in the ass. So I did change to include that, but we have to make sure that we're writing things correctly. On some of your multiple attempts, I just kind of like went through your multiple attempts and put together a correct quiz for you based on some of your answers. So I just gave you the points so you wouldn't have to do it again. So sorry that you had to go through that. Try to fix it. Any questions? Incidentally, we still have this discussion. If you're thinking it's like, oh, talking to computers is a pain in the ass, why can't we just write things down and have you look at it? It's still, we run into exactly the same discussion. I just come at it from a slightly different angle, and I have to tell you how to write stuff down. So the same discussion still happens, even if we're writing stuff down on paper and handing it in. We still have to be precise in our communication. Let's see. Some things that places that we can avoid parentheses. If our parentheses don't, if our exponent or numerator or denominator doesn't contain an operation, then we don't need parentheses. Parentheses are really specifically to call out additional operations. So we don't need parentheses if there's no operation. This one came up with, let me come up with one at random. One of them connected to nothing was 3.14 x to the 2.14. Now the 2.14 is a little bit more messy of a number than just like 5x, like a 5x to the 4. But 2.14 is still just a constant. There's no operation here. There's just a decimal point. So if we want to write this in single line syntax, 3.14, no operations here, no parentheses necessary, x to the 2.14. So we didn't need parentheses, even though the 2.14 is a little bit messy of a number. It doesn't contain any operations. So that's why when you put 3.14x to the parentheses 2.14, it got marked wrong. I didn't think anybody would do that. Some people did, got it marked wrong. So I just made a note. Any questions? How's everybody okay? All right, so those are the things that I noticed on the problems that we had yesterday. Let's see. I did kind of, well, so notice that one of the examples that we had yesterday, R of x, I typed it this way, 6 over x to the 2/3. Now you notice that I did not include parentheses around the denominator here because even though it has operations, so it's almost like I'm breaking my own rule, right? There's an operation in the denominator. There's an operation in the denominator, Why didn't you use parentheses? So right now you're thinking there's an operation in the denominator. Why no parentheses, Leach? You might be thinking, are you going against your own rules? What's the difference between this expression where I didn't write parentheses and why I was like, oh, you need parentheses here. And why did I like, oh, just ignore that here? Notice that in the previous one, there's a coefficient in front of the x. It's 5x to the 2/5. In this expression, there's nothing in front of the x. I'm saying 6 divided by x to the 2/3. So the only operation in the denominator is this exponent. There's no order that we have to try to figure out. X is getting raised to the 2/3 power. We take 6 divided by the result. Up here, there are operations that are at the same level. There's a division and a multiplication. I have to make sure that this multiplication goes before this division. Otherwise, we just start marching through multiplication division from left to right. So we need parentheses around the numerator and denominator with operations when they're at that same level or a lower level. The exponent is sitting at a higher level in the order of operations. That's at the top of our order of operations. So there's no way, there's nothing that would indicate that we would take 6 divided by x, then raise the result to the 2/3 power. If I wanted that, I would have put parentheses around the 6 divided by x. Although if you do want to call me out, you should have parentheses around that. That's fair. I mean, I just said you need parentheses around denominator with operations. The way you want to read this particular expression. So the reason is exponents are above multiplication and division. The order of operations places exponents above the order before. The order of operations places exponents before multiplication. And those are the two operations that are going on here. The exponents and then division. Division and multiplication, same thing. The way you want to read r of x is 6x to the negative 2/3, or 6 times x to the negative 2/3 in single line syntax. When we write the derivative of this r prime, we have 6 times the negative 2/3. 6 divided by 3 is 2 times negative 2 is negative 4. X to the negative 2/3 minus 1, which is negative 5/3. This is how we were thinking about the problem. And I figured this is how students will type their answers. I was not correct. A lot of you got this correct and typed it slightly differently. I thought I was clever because I'm like, oh, what if they put the negative in front? 4x to the negative 5/3. I put those two and I'm like, oh, that should cover it. I need Morgan Freeman to assist me during class. That did not cover it. So if we want to write this with a positive exponent, if we want to make the 5/3 positive, we could take negative 4 divided by x to the 5/3. And I should have been accepting this answer. Because like our original problem, it has that same form as the original problem. I expected you to keep the multiplication from when we write x, a power of x. I should have been accepting this answer. So I have to go through and I have to fix that. So if you missed this last one and you wrote -4 divided by x to the 5/3 and you submitted it a bunch of times and you're like, oh, dude, that is the same thing. I gotta go and fix it. The other thing that would need to be acceptable. I should allow for the fact that you might read this as having an operation in the denominator and wanting to clear up confusion by putting by putting parentheses around the x to the 5/3. That should be acceptable as well. Any questions? One of the difficult things that we run into when we're typing math is I have to think of all the possible ways that you could type your answers. Or use some kind of reader like GeoGebra that reads equivalent expressions. The problem with those kinds of systems is that they don't always read equivalent expressions. One of the problems that we run into is that math is shorthand for a very precise set of instructions. And one of the difficulties that we have is that I'm communicating these instructions, I'm communicating these expressions using English. And English is a terrible language for communicating precise instructions. All of our spoken languages, by the way, are terrible at communicating these precise instructions. That's why we have math and we have to agree to all these rules. It is very difficult to write down precisely what we mean. So for example, if I write down an expression, I want you to think about how you would read this expression. That's the difficult part, by the way. I want you to read the expression without just spelling it, because that's not how we talk. Until we get to a complicated expression. So like I might go to a coffee place, like, what name can I put on the order? And stupidly, I just give them my name. I call Evan. And then so I just have to make sure. I was like, oh, I just gave them my name. So I have to make sure that when I'm getting I'm waiting for my coffee, I'm waiting for Kevin's coffee and hope that there wasn't a Kevin in front of me in the line, right? Because depending on what the barista's experience is, they might not be familiar with the name Evan, even though it's a little more common now. You know what I mean? Some of you know what I mean. There's probably like a Bob in the class. It's like, oh, I don't know what you're talking about. So sometimes I'll be like, oh, Evan, E-V-A-N, or Leach, L-E-A-C-H, which I've been doing since 7th grade, and I found out what flatworm was called. I remember that day distinctly. I'm sitting in Mr. Trenter's science class, 7th grade science class, and it's like, oh, this is an example of a flatworm, also known as this particular one is called a leech. And everybody in the fucking class turned around to look at me. Is he a vampire? I'm like, fuck you guys. It's a fucking flatworm, and it's not even spelled the same way, even though it secretly has the same origins. My name is because someone in my family over on that island was like, oh, you have bad humors, and like, we gotta suck those out of you. Here, put some leashes on you. So someone in my family was doing that. I'm kind of embarrassed. Ah, bad humors, eh? Let's drain some blood out of you. Ridiculous. Anyway, I want you to read the expression without just spelling it. I want to write the expression. Think about how you would read this expression. Everybody have some words with this expression? How many of you were thinking 2x minus 5 cubed? 2x minus 5 cubed, that's like literally what it says, but what's missing when you say it that way? We're missing that grouping symbol, right? Because if you just say 2x minus 5 cubed, if you just say 2x minus 5 cubed, if you just say that out loud, someone's going to write 2x minus 5 cubed. And they'll be like, oh, why did you just say 125? You're like, well, that's not what I meant. Does that make sense? If you're like, oh, the quantity 2x minus 5 cubed. There's the quantity 2x. Here we are minus 5 cubed, right? That doesn't help, right? Because the quantity just kind of like starts something, but it doesn't finish it. If you're like, oh, open parentheses, 2x minus 5, close parentheses, cubed, now you're just spelling space it, and that's not how we communicate. Make sense? Anyone think to lead with the cube part? The cube of 2x minus 5. That would certainly do it, right? What's wrong here? At least I said 2x. That kind of crams those things together. The cube of 2x. That's the most likely thing that would happen. But that's where the cube is going to stop. And the person's going to be like, oh, why did you just say 8x cubed minus 5? Right? The cube of 2x minus 5. Now, if someone really wanted to mess with you, you'd be like, oh, the cube of 2 x minus 5. Right now they're really messing with you. That makes sense? This is why we write this expression. So that we can differentiate between all these different things that might happen, all these different ways that we can combine these expressions. Anybody have an alternate reading? The point is, it's very hard to make me write this exactly without just spelling it. The problem is this is the cube of, and then we want stuff going on inside, right? It's the cube of a group of things. It's the cube of the difference. By saying the cube of the difference, I'm saying something minus something, all that to the third power. The cube of the difference. We have to name that quantity rather than just say generically quantity. So the cube of the difference between, and then we could call this 2x or twice a number. and 5. If we say the cube of the difference between twice the number and 5, no one can mistake that for anything but that expression. If you want an easy way to figure out how to read an expression, write down what order the operations happen in. The order of operations, what's the first thing that would happen to the x in this expression? If I plug, say, x equals 10, the first thing I'd want to do is multiply it by 2. So I'm going to write down the first thing that happens is multiply by 2. Next, we're going to subtract 5. And third, we would raise to the third power. That's the order of operation that turns x into this expression. If we want to read what this expression is, read it this way. The cube of the difference between twice a number and 5. You will always be able to write concise, precise expression if you read it backwards. That's not how we would execute the expression. The expression is done this way. This is the do things in this order. But if you want to read it, or if you wanted to solve the equation, this is the reverse order. You just do inverse operations. If you wanted the inverse of this expression, first do a 1/3 power, then add 5, then divide by 2. That's how we could solve an expression or an equation involving this expression. Any questions? Is that right? Okay. So I realize this first quiz and the other one that's going to show up that'll be like it is frustrating because we have to try to communicate our ideas in addition to learning how the stuff works. How's everybody okay? Scoring wise, I guess this could be recorded too. The way that this is scored, there's 12 points available for this on Canvas, and you can get all of those. And there was 4 points for just being here yesterday. I'll turn this in. I don't care how many you got right. There's 4 points for just participating in the activity. But the bulk of the points was on the Canvas turn-in. I'm going to pause and I'm going to return these to you.